Right, hello Year 8. So today what we are going to be doing is starting a new topic looking at atoms and the structure of atoms. Before we do that though, you need to go into the chat and I uploaded the answers from the end of topic test. Can you please check your answers and later send me your score? Okay, so once you've done that, what I would like you to do is put in today's title and then also write these 5 questions down, okay, and leave a little bit of space underneath in your book or wherever to try and answer them, because some of them you might be able to answer right away, some of them you won't be able to answer until we've actually done the entire lesson. So write these questions down, and you could start now by writing what your current knowledge is. So for example, what is an element? Based on what you've learnt in chemistry earlier in the year, what is your understanding of what an element is? Okay, and then the same with the atom, what they're made from, what are these, and can you draw the structure of an atom? Okay, so where our knowledge already lies, try and do that now, but try and leave a little bit of space to update your answer as you learn stuff today. Okay, so pause the video and do that now. That'll probably take you about 5 minutes. Okay, so welcome back. So by the end of today, all of you should be able to list the 3 types of subatomic particles atoms are made from. Most of you will be able to explain the properties of these 3 types of subatomic particle, and a few of you make a model of an atom showing the structure of an atom using the periodic table. Now, we were going to do this with counters in class, but you can probably just get away with drawing this in your book, okay? So, the first thing I'm going to do is, in assignments, there is this link here, which is to a YouTube clip. I want you to watch the first sort of 6.5 minutes, although if you want to watch it till the end, it's only about 10 minutes long, although the last few minutes isn't really relevant. I would like you to try and answer these questions, okay? Now, I was going to upload a sheet, but it's probably actually quicker just to simply write these questions down in your book and then answer them as you are watching the video. So to pause the video at certain points and answer these questions and to watch the video itself will probably take you about 10 minutes. So once again, pause this tutorial now, go into assignments, click on this link, watch the video and answer these 6 questions as you go. Okay, so pause this and do that now, please. Okay, welcome back. So what you should have picked up from the video was this, okay? There are essentially 3 subatomic particles. And a good way of laying this out is in a table like this, okay? So you can actually sort of classify everything. So your first particle is the proton. Then comes the neutron, and finally the electron. Okay, so what do we know about them? Okay, right. So I'm going to sort of fill this in a slightly strange order because I think it'll help you sort of make sense of it. Okay, so firstly, where is it found in the atom? Now, the proton is found in the nucleus. Okay, so that's the part which is like the center of the atom. Okay, and the neutron is also found in the nucleus. Now, don't get confused with the nucleus of a cell. Okay, ooh, nucleus. Don't get confused with the nucleus of a cell. Nucleus sort of means center. Okay, and that's essentially what this means. It's like the center of the atom. Okay, and protons and neutrons are very similar in certain ways. Okay, they both have a mass of 1. Okay, now when we say 1, we don't mean like 1 kilogram or 1 gram. It's just a standard atomic weight. We just say a proton has a mass of 1, and so does a neutron. So essentially, they have the same mass. So if I had a proton and a neutron in a nucleus together, I'd have a mass of 2. So, for example, I had 6 protons and 6 neutrons. I have a mass of 12. Okay, so we can start to work these things out as we go. Now, this is where it gets a bit different. Okay, protons have a positive charge, a charge of +1. Okay, so this is where they start to get a bit different. These ones have a positive charge. Neutrons, as the name suggests, are neutral. So their charge is 0. They have no charge, neither positive nor negative. Okay? Now, the electron is slightly different. Okay? Now, the electron is found circling the outside, okay, of the atom. So we'll say orbiting, okay, orbiting the outer part of the atom. Its mass is basically 1,800 times smaller than this. So it'd be 0.00, I think it's 0.1. Okay, so their mass is essentially 1/2000th, sorry, 0.05. Okay, it's 1/2000th, or actually, I'll put it another way, 1/2000th of one of these. So it's basically, you know what, let's be really accurate. There we go. So, as you can see, it is much, much more. So say, for example, if they're 1, this is 1,800 times smaller than either a proton or a neutron. So, because their mass is so small, we don't really count their mass at all in the atomic mass. Okay, when we're talking about mass later, we don't count the mass of the electron at all. They're really involved in chemistry, but not really involved in the mass. Now, the electron, I'm wondering if you can work out what its charge is. Okay, now an atom has an overall neutral charge, so it has neither a positive nor negative charge. Now, if the nucleus has got positive charges in protons and neutral or no charge in neutrons, if the whole atom is going to be neutral overall, then the charge must be negative or -1 to balance out the positive charge. So, ladies and gents, what I would like to do, if you didn't quite get this earlier, pause the video and copy this up. These are the main key properties of atoms. Okay, so pause that now and off you go. Okay, welcome back. Now, what we need to do is actually understand what some of these things are. So if you ever have a look at a periodic table, it gives you all the information about that atom. Okay, so for example, let's take O. Now, most of you know what this is. This is oxygen. Okay, the first number that you'll see is a small number, and that is the atomic number. That is the number of protons. So we know that oxygen has 8 protons. Okay, now this next number down here is the mass number. Now, the mass number is the number of protons and neutrons together. It's 16. Now, we can do a little bit of clever maths here, because I could ask you, what is the number of, say, neutrons in an oxygen atom? Now, let's work this out. Now, this number here is the number of protons and neutrons together. We already know there are 8 protons, so therefore, to get to 16, how many neutrons are we going to need? So those of you can do basic maths, it is of course 8. So we know that oxygen also has 8 neutrons, even though it's not actually shown anywhere else. Carbon is here. Okay, so this is carbon. 6 protons. How many neutrons does it have? Well, the mass is 12, so therefore, it's already got 6 protons accounted for, must have 12 neutrons. Now, some of you will think, is it always the same? In many atoms, it is. The number of protons and neutrons are the same, but not always. And so you've got to keep your eyes open for that. Okay, so what might be a good idea is to quickly pause the video and copy one of these up and label it as an example. Okay, so what does the mass number mean? And what does the atomic number mean? Okay, so pause the video and do that now. Okay, so what we can do is we can arrange atoms in and show how they're arranged in a particular way. So drawing atoms using the periodic table. Now, to help you with this, you might want to pull up on another screen, or if you've got a revision guide, the periodic table. And I'll explain why in a minute. Now, helium is the second simplest atom in the periodic table. Okay, second simplest one. Okay, and I'm going to talk you through helium a little bit. Okay, so helium is an element. Okay, and the things that define helium as helium are essentially its atomic number. So its atomic number is 2. Think what that tells us. It must have 2 protons. Its mass is 4. Okay, they've done it as 4.00, but it's 4. Its symbol is capital H, lowercase e. Now this is also interesting. Every element, you'll notice, starts with a capital letter. Some, like oxygen, are just single letters of the alphabet on their own, O. Some, like helium, have a second letter in lowercase. That's because just H on its own was already taken by hydrogen. So because it begins with H as well, they put a little e to show that it's helium. All right? And then, of course, actually tells you that it's helium as well. So let's look at what we've got here. An atomic number of 2, an atomic mass of 4. So we're going to have to try and build this. Now, firstly, what do we need? What is the atomic number? Well, the atomic number is the number of protons. So let's put these in. So, whoops. There we go. Protons, 1, 2. So you can see there, I've got my atomic number 2. There it is. Now, in my nucleus, in my central part, I've also got neutrons. So let's put those in. There we go. So I've got 2 protons and 2 neutrons. So my atomic number, the number of protons, which basically makes the atom what it is, that's there. And the atomic mass is 4. Don't ignore that little number, it doesn't really mean anything. Right, now the electrons, they circle around the nucleus in what we call orbital shells. And you're going to learn about those in a few lesson times. Now, the atom overall, remember its charge, has to be neutral. Now we've got 2 positive charges, 1, 2. So at the moment, its charge is +2. Electrons are negative. So if we add these in, there and there, what they'll do is they'll sort of whiz round in an orbit like this. They'll kind of whiz round really quickly and they'll orbit. And imagine the other one doing the same thing as well, sort of orbiting around like that. Okay, so they orbit in these very distinct shells. So that's basically a helium atom. Okay, now a couple of little pointers here which you're going to learn later on. The electrons have to be in these shells. The nucleus is contained within the center. The electrons have to be in these shells. The first shell can have 2. Once it's got 2, it's filled, and then they have to go to the next shell. So let's see who's been paying attention. What I would like you to do is firstly draw that. So pause the video and draw that, and then you're going to try the next most complex element in the periodic table. So pause the video and do that now, please. Right, welcome back. So firstly, what you've got here is the next most complicated element in the periodic table is lithium. You've got 3 protons, 4 neutrons, and 3 electrons to play with. So what I would like you to do is pause the video, and then once you think you've got the right answer, much like what we did with the helium atom a moment ago, restart the video and we'll check your answers to see if you're correct. And then you can draw it in. So pause the video and do that now, please. Okay, so what you should have got was something that looked like this. Now remember, the atomic number of lithium is 3. So it's going to have 3 protons in the nucleus. 1, 2, 3. The atomic mass is 7. Now remember, the mass is protons and neutrons together. So 1, 2, 3 protons, 4, 5, 6, 7 neutrons. So lithium would be atomic number 3, atomic mass 7. Okay. Now, the number of electrons have to be the same as the number of protons. Remember, these have a positive charge, which means these must have a negative charge. So 1, 2, 3 positive charges means 1, 2, 3 negative charges. They have the same, because it's neutral overall. And for those of you that were really paying attention, first two electrons go in this first orbital shell, this first orbit, but that's now filled because you can only have two. So this one has to go in the next shell. And so it looks something like that. So if you didn't quite get it, pause the video now, draw that into your book, please, and then we'll try one more. Okay, so this time we're going to do carbon. Atomic number 6, mass 12. Okay, so once again, pause the video, draw it in, see what you would have got. Okay, welcome back. So you should have got something that looked a bit like this. So your nucleus has 6 protons, so an atomic number of 6. 1, 2, 3, 4, 5, 6. There they are. And a mass of 12. So remember, mass is protons and neutrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There it is. There's our nucleus. Your electrons, you should have 6. 1, 2, and then into the next shell, 3, 4, 5, 6. So that's carbon. So again, a little bit more complicated. Okay? Right. Okay. So what I would like you to do is, in assignments, there is a very quick thing to run through. It's PowerPoint, and it's just a really quick test. It should only take you a couple of minutes, and it's just true or false. So basically, read the question, try and answer it yourself, and then you can just quickly press the answer to see whether or not it was true or false. That's just a quick stop check. Okay, so pause the video and do that now, please. Okay, so if you're feeling really clever, you can now try doing something even more complex. You could try, for example, an oxygen atom. Or if you think you can try one even further along in the periodic table, have a quick look at the periodic table and see if you can spot anything that you fancy trying to draw a model of. Maybe probably don't go for one which is too hard, but see what you can come up with. Okay, oxygen's quite a good place to start. Right, and then finally, also in assignments, you will have noticed there's a Word document. Okay, that is your final assignment. So that will hopefully test your knowledge of what you've learned today. So you can either print it off and fill it in, or you can answer the questions in your book. And that should probably take you about 15 minutes or so to do that, because you've got to think a little bit about that. And then I'll upload the answers at the end of the lesson. Okay, so one last thing before you finish. Sorry, don't forget to log back in onto this tutorial before you finish. One last thing to show. Okay, year 8, welcome back. So what I asked you to do at the beginning of the lesson was write down these 5 questions. What I would like you to do now is any additional knowledge that you now have from this lesson, I want you to now try and answer these questions again. So some of you hopefully will have learned some new things today. Okay, so you can write your answers underneath these questions. Hopefully you left enough space, or if not, just write them wherever you can find room in your book. Okay, so the answers to the assignment will be uploaded in just a moment. Good luck. Hope you did okay, and I will see you on Wednesday. Take care.